let's do this, which will get us back to card hands, which everybody has enjoyed so much last time. I was actually pretty pleased with the lecture to be able to like end with the last hand as the bell sounded. I was feeling on top of my game, as it were. Okay, so let's suppose that aces can be high or low. So you've got that. So ace 2 3 4 5 is a straight, and so is 10 jack queen king ace. Okay, that piece of information is sort of irrelevant for the question that's about to be asked, but there's some versions of the question when you reload the page where it matters. It doesn't matter for this one, so don't be distracted. The number of ways of getting a 5-card hand that is 4 of a kind from a standard deck of cards is question mark. We did that last time. We'll do it again. And the probability of being dealt a 5-card hand that's 4 of a kind from well-shuffled deck of cards is, and that's the new piece this time. So if we shuffle a deck of cards well, what do we mean for the deck to be well shuffled? Okay, it means that it's in an order that's random, and in particular, every possible ordering of the deck is equally likely. That's what we mean by well shuffled. Okay, that it's just as likely to be ace 2 3 4 5 6 7 8 9 10 jack queen king of spades, followed by ace 2 3 4 of hearts, followed by, as it is to be 7 of diamonds, followed by 2 of clubs, followed by 3 of hearts, followed by whatever. Right? They're all, every permutation of the 52 cards is equally likely after shuffling. How many permutations are there of 52 cards? How many orderings are there? 52 factorial. This meets the definition of ginormous number. Right? It's big. Okay. All right. Okay. So first of all, how many ways are there of getting 4 of a kind in a 5-card hand from a standard deck of cards? Okay, we'll do this a slightly different way from what we did last time and see if this way of approaching it makes more sense to some people. We're going to look at a particular hand that is 4 of a kind, and then see what we could have done differently in order to see how many other 4 of a kind hands we might have gotten. So let's look at ace of spades, ace of hearts, ace of diamonds, ace of clubs, king of spades. Now there's a really nice 4 of a kind hand. Okay? Now, how do I generalize this? What could I have done differently? Well, this card, after I've taken out the 4 aces, there are 52 cards in a deck. 4 of them are aces, 48 of them are something else. Any of those 48 cards could have been here, right? So I have 48 possible choices for this. This place could have been any of 48 things. Okay. That's for a particular choice here, but this choice didn't have to be the aces. Instead of getting the 4 aces, I could have gotten 4 2s. I could have gotten 4 3s. I could have gotten 4 7s, whatever. Does this make sense? Okay. How many different things could I have done here? There are 13 different kinds of cards in the deck. So I could have done that in 13 ways in all, including this way. All right. For each way, no matter what I pick to have 4 of a kind of, I have 48 choices for the odd card. Yep. So the total number of ways that I could do this is that, just 13 times 48. Does this make sense? Is it right? Have I misled you? Have I pulled one over on you? By 4? Where were the 4 what? For getting the 4 aces? Okay, so it's a good question. So why isn't there something to do with the fact that there's 4 here? The answer is, having picked that I'm getting aces, there's only one subset of aces I can get that gives me 4, namely all of them. So if you like, there's a 4 choose 4 factor. So 4 choose 4 is 1. So that's what's going on. Yes?
Do you have to take into account the suit of the extra card?
Okay, do I have to take into account the suit? So this, the answer is yes and no. There are two ways of doing it. This way of doing it, I'm just saying any of the remaining 48 cards would work. Okay? A different way of doing this would be to say, well, okay, instead of getting the king of spades, I might have gotten a different king. Okay? And in fact, there are sort of 4 other suits I could have gotten of the king. But I didn't have to get kings. I could have gotten any of the cards that aren't aces. There's 12 ways I could have done that, and this is still 48. So it's a different way of solving the same problem. There's always more than one way to solve these problems. There's even more than one right way. Other questions about this? Okay, so if 13 times 48 is the number of 5-card hands that are 4 of a kind, what's the probability that I am dealt 4 of a kind out of a well-shuffled deck of 52 cards? Okay, what am I going to divide this by? Okay, so there's 52, choose 5-card hands that I can get. Now again, the scenario here is I am dealt 5 cards, I pick them up, it's a set of 5 cards, right? It doesn't matter what order they were dealt to me, and what matters is that those are the 5 cards I got. Okay? So that's why we're looking at sets of 5 of the 52.